Copper 2 complexes are coloured. The colour is caused by the d electrons of copper moving from their ground state to an excited state. Explain why aqueous solutions containing CuCl42- ions are yellow. So what we're needing to explain is how we can appear yellow, what sort of processes are happening. And so we want to be saying that our complex, our CuCl42- ion, absorbs certain frequencies, so not all of it, but certain frequencies of the visible part of the spectrum, so of visible light. This causes the d electrons to be promoted from the ground state to the excited state, but that's already been written into the question, so I wouldn't need to say that. The remaining frequencies of visible light are transmitted and because we're seeing yellow, this must be yellow light. When a d electron moves from the ground state to the excited state, the energy change, delta E, is 3.98 times 10 to the minus 19 joules, and Planck's constant is 6.63 times 10 to the minus 34 joules second. Calculate the frequency in seconds to the minus 1. So we're trying to remember the equation E equals H, Planck's constant, times frequency. Now, if you're in the exam and you forget that, try to look at the units. You want an answer in seconds to the minus 1, and you've got a number in joules and a number in joules second. So if you were to take the number in joules, see that's in joules, and we were to divide it by the number in joules seconds, we can see that the joules part will cancel and we'll be left with seconds on the bottom line, which will give us our answer in seconds to the minus 1. So even if we'd forgotten that, we would need to do the energy divided by Planck's constant to get the frequency. We could see it from the units that that's what we would need to do. And on our calculator, that is coming out at 6.00 times 10 to the 14 per seconds. State 3 ways that a transition metal complex can be changed to alter its colour. So we could change the ligand. So instead of having chloride ions, we could have water, and that would be a different colour. We could change the coordination number, and we might see a different colour. And we could change the oxidation state of the metal. So we could oxidize or reduce the metal. Consider the following scheme in which P, Q and R are different complexes of copper. Now notice that they're all AQ, which in transition metal complexes mean that they're all charged species. Name the shape of the one we've got 4. So when we've got 4, we're either tetrahedral or square planar, but with chloride ions on copper, we're tetrahedral. So we want to go from CuCl4- to P. So we're changing the ligand to water, and when we have the water, we're going to have the hexaaqua ion, and that's got 6 waters. So we're going to go 6 waters and a 2+ charge, but we're actually being asked to write an equation, not just give the formula. So I'm just going to move that over because we're going to form that from CuCl42-. We're replacing the 4 chloride ions with 6 waters. I should check our equation. It should balance for both atoms and charges. Give the colour of Q. So Q is when we add excess ammonia. We have to remember when we add ammonia to copper, that's the sort of odd one out. In excess, we get this 4 ammonias and 2 water complex. So we've got to give an ionic equation for the conversion of CuCl4 2- into that complex Cu, 4 ammonias, 2 waters, two plus. So we must have had to add the 4 ammonias, we must have to add the 2 waters, and we can see that what we've got left over is the 4 Cl- ions. And what colour this complex is? This is the complex that's the lovely deep blue colour. Then it says identify complex R. So we're looking at this and we're trying to remember. So we've got these 4 NAs. So we know that EDTA must be a 4- ion, but we're trying to remember what sort of ligand EDTA is, and it's hexadentate. It has 6 atoms that can form coordinate bonds. And so we're going to take the copper that's 2+. EDTA is going to take up all 6 spaces around it in the octahedral shape. And because the copper was 2+ and the EDTA is 4-, then our complex ion has a 2- charge.